Well, you've made it to the last video in the course. Congratulations. I hope it's not been too bad. Here we're looking at future value. It's a sinking fund type of payment, and we're going to use the future value formula and solve it for R. So we're going to be trying to find the payment needed to accumulate a certain amount of money. So to solve for R, we're going to do like we did in the last one and take the reciprocal and multiply both sides. So R is equal to, that S is still going to be there on that side, and we're multiplying by the reciprocal now. We'll have I over 1 plus I to the n minus 1. So your book just puts these two together and has SI at the top. So R is equal to, and then it keeps this stuff on the bottom. So R, just like before, is the payment, periodic payment required to accumulate S. That's required. And N is just that number of payments. So that's going to be your M times your T. S is going to be the accumulated sum that you're wanting to get to. So that's the future value. And I is that interest rate per period, that R over M. And this is also given on the test, or any other assessment like a quiz. Looking at just a few examples, we've got a self-employed individual who wishes to accumulate a retirement fund of $550,000. How much should they deposit each month? So here's the difference in our problems that we had before. We're looking at monthly deposits, not a lump sum amount. We're putting it in an account that pays interest at a rate of 5.5% compounded monthly, and we're going to assume, of course, just like all the other problems, that's a constant rate to reach this fund goal upon retirement 25 years from now. All right, so we could use this formula or we can use the TVM solver. Of course, I'm going to show you both. So the sum that we wish to meet is the 550,000, so S is 550,000. And I, of course, is R over M, so we'll have 0.055. And this is compounded monthly. And how many years have we got here? 25. So N is equal to 12 times 25, MT. So R, we've got 550,000, and then times the 0.055 over 12, divided by 1 plus R over M to the MT, so that's our N, and then minus 1. So again, plugging into the calculator might help working backwards. Alright, I think I've got it this time. Let's go ahead and type that in. Nope, missed something. Let's see, I guess I've got an extra parenthesis. Hold up. Go back through our parentheses here. Nope. I didn't start this one over here. Sorry about that. Okay, so we've got approximately 856.65. So this individual should deposit approximately $856.65 in order to meet their retirement goal of $550,000. So let's do the same thing on the TVM solver. N is equal to MT, so that's that 12 times 25. Our interest rate is 5.5. Remember, we don't put it into a decimal. Present value right now is equal to 0. The payment is what we're trying to figure out. The future value, we want to reach $550,000, and we're compounding monthly, so 12. So let's figure out what that payment needs to be. Alright, so the payment needs to be $856.65. Here we have Jennifer, who's an owner of a video game and entertainment software retail store. She's currently planning to retire in 30 years and wishes to withdraw $14,000 a month for 20 years from her retirement account. How much must she contribute each month for 30 years in an account that's earning interest at the rate of 5% per year, compounded monthly, to meet her retirement goal? So we've got two things going on here. First, we have to determine the present value of the retirement account. So in other words, how much is going to be needed to fund that stream of payments that's going to occur after she retires. So after that annuitization phase. And then we need to figure out the sinking fund payment. So let's do this part first, and then we'll go on over there. So we could use the formula P equals R. So we would need $14,000. Remember, that's your payment. R over M, so the rate would be 0.05, and that is monthly, to the negative MT. Now here's the thing. We have to figure out if we need to use the 20 years or the 30 years in this particular one. So which set of years is she withdrawing the $14,000 for? Well, it's for the retirement, and she's planning to retire for 20 years. She's going to be withdrawing this payment. So we need to do T of 20 for this one. All right, and then I is going to be R over M. So let's see if we can get that typed in. Let me write it out first. Okay, so we're dividing by 0.05 over 12 and multiplying everything by the 14,000, raising that parenthesis in the numerator to negative 12 times 20. And it's everything that's in that big parenthesis. 0.05 over 12. 1 plus, and then 1 minus. Okay, I think that should work. Wow. This comes up to 212,1354.38. That is a lot of money. She's going to need $2,121,354.38. So let's go over here to our sinking fund payment. That means that's going to be this accumulated amount that she's going to need. So we're going to have to figure out what payment she's going to have to make in order to have that much money upon retirement. And she's got 30 years to be able to save that and grow that much money. So let's check out that payment. So she's going to need to have that 2,121,354.38. And then the I is the R over M. So R over M over the 1 plus R over M to the MT. And remember, she's saving more than she's withdrawing, thank goodness. So she's saving for 30 years. And then minus 1. So in the calculator, the steps would be 2,121,354.38. And I guess we're multiplying it everything here So we'd have 0.05 over 12, and then dividing by that whole denominator. And then the whole parenthesis with the fraction here. And I believe that's got it. So let's just go second minus sign, the negative sign, to get the answer up there that we just had in, and then let's do parenthesis, and start with this right here. All right, so this is equal to 2548.91. She's going to have to save a lot of money per month to have that on retirement for 30 whole years. Now we need to see how to get the same result for Jennifer from the TVM solver. So her number of payments, she had 12 times 20. And her interest rate as a percent was 5. Present value is what we're trying to find. Now her payments, normally we've been using negative, but remember she's going to be receiving these payments in retirement, so we're going to make that a positive 14,000. And she's going to get her account down to 0 at the end, and she's going to receive 12 payments per year. Compounding is the same. So let's see what happens here. So 12 times 25, trying to find present value, positive 14,000, future value of 0, 12, 12, so let's go up to present value. This is how much she's going to need to be able to fund those payments. So alpha enter. She is going to need 21,21354.38. Exactly what we found up there. And notice that that's a negative number. That's how much she's going to need to pay into the other account. So that's where the sinking fund payment is going to come in, because that's going to tell us how much she needs to pay per month to be able to have this much by the time that she retires. Okay, so over here we've got number of payments as, let's see, 12 times 30. The interest rate is still 5. The present value is 0. The payment amount is what we're trying to figure out. The future value needs to be the 21,21354.38. Payments per year, compounding periods per year. So we got 12 times 30, 5. Present value is 0. We don't know the payment. The future value needs to be how much is in the account. And we go up to payment. Alpha enter. And that's where we see the 254891.